My name's Gale Ekiss. I'm the co-coordinator of the Arizona Geographic Alliance, and I'm going to share a lesson called The Ups and Downs of Population in Regions. It's designed for 5th grade, and it lasts between 1 to 2 class periods. The overview of this lesson is that math manipulatives, or in this case we're going to use Legos, help kinesthetic learners learn geographic concepts and see spatial patterns. This lesson will help students formulate a mental map of the United States and they will see the regions of the United States in this mental map. They will also discover there's a relationship between population density and the elevation of land. So in this lesson, students will learn how the elevation of land can directly relate to population density. All right, for materials. You need several thousand Legos, and you need to divide them into baggies. You need 84 Legos in total, but you need 42 of 2 colors. So in my baggie, I have red and blue Legos. You also will need a base to build your graph on. And in this case, it's the Lego base, but there's something that's been added to it to stiffen it and make it last forever. My shop teacher at school bought masonite, and he cut it into a strip that I guess is about 1.5 inches, 1 1/4 by about 8 or 9 inches long. And he laminated the 2 pieces, the plastic to the masonite board, with some sort of special glue from the hardware store. These have lasted for 20 years now. So it's an excellent way to preserve the plastic and utilize this activity. The other thing that you're going to need for this lesson is graph paper that's provided in the lesson, colored pencils, and a series of worksheets. The objectives for this lesson is that students are going to create a double bar graph that displays geographic concepts. They're going to divide whole numbers, and they're going to analyze data that shows a relationship between elevation and population density. Prerequisites for math are that they need to be able to do long division problems and round off numbers to the 100th place. The prerequisite geography skills is they should have some geography vocabulary behind them. They should understand that the word elevation means the height of land above sea level, that sparse and dense. Sparse means few, but in this case it's few people per square mile. Dense means many people per square mile. And when we talk about population density, it means the average people per square mile. And they should also have some familiarity with the 5 physical regions that are identified by the Arizona State Standards, which are the Northeast, the Southeast, the Midwest, the West, and the Southwest. So in session 1, we're going to do a mental mapping activity. And this is a kinesthetic activity, but before we can do that, we need to have the students study the map that you see on the PowerPoint slide. This is a map of physical regions of the United States. So give them a couple of minutes to individually just kind of look this over and kind of memorize, but point out that on the left side there is a scale that shows elevation, so that they should understand the elevation scale on the left side. After they have studied the map for a few minutes, we're now going to do a kinesthetic activity that's going to involve their arm. So you have them sit in their desk or stand, whichever you choose. I would prefer to have mine stand. And they're going to raise their right arm to their shoulder level, so it's straight outside their body, and tell them that this arm is at sea level. Now, I am sitting opposite to you, so I have to kind of go backwards on this. But you're going to see that if they stand with their arm out, this should be the Atlantic Ocean. And I am at sea level at the Atlantic Ocean. Now, thinking back to the map they just looked at, the Atlantic coastal plain is pretty much at the same elevation. So Atlantic coastal plain would be about at the same height. Then we had, for the next region, the Appalachian Mountains. So the mountains go up a little bit. So their arms should go up. Then we have the Mississippi River and the Great Lakes area, which goes down again. Then we have the Great Plains. It's coming up a little bit more. The elevation's a little higher. And then we have the Rocky Mountains, way high. And then we have the Great Basin, comes down some. Then it goes back up for the Sierra Nevadas and the Cascades. And then we go down to the Pacific coast, which would be about where your other shoulder is. All right? Have them do that several times. It's really important for those kinesthetic learners to see that this is the elevation, that they can actually do it with their body and get a sense of where our highs and lows are for the United States. Then you're going to explain that they've been estimating with their body where the highs and lows are in elevation. But now they're going to do some data. They're going to use some data to discover how elevation relates to population. And you have a worksheet that will be used for their math computations. Now I'm putting down the answer key, but they obviously would have one without the answers. And they're now going to look at the directions, which say that they're going to be making a double bar graph eventually. They have to do the math problems in order to figure out how to do the double bar graph. And the first thing they have to do is look at or determine what the elevation is in above sea level, but they're going to take these calculations and determine how many Lego blocks would be represented by that elevation for that region. So the first region is the Pacific Coast. The Pacific Coast averages about 1,000 feet. 1,000 feet divided by 500, because each Lego block will equal 500 feet of elevation, would be 2 Lego blocks. So they would fill in their worksheet with a 2. Sierra Nevada, Cascade Mountains, the average elevation is 3,500 feet. They would divide it by 500. They would come up with 7 Legos. And then they would complete the worksheet for that first part of the elevation. The way they check their math is if they've answered all of the division problems correctly, they will have 34 as a total for how many Lego blocks they're going to need. The second part of the math sheet deals with population density. Now we have about 4,200 people per square mile in the Pacific coastal area. You're going to divide 4,200 people by 500 to get the number of Legos. That would equal 8 with a remainder of 200. 200 over 500 is not enough to round up, so you would drop it off. So you're learning about rounding as well as dividing in this particular part of the activity. Sierra Nevadas and the Cascade Mountains, there's about 1,200 people per square mile. Divided by 5 would equal 2 blocks, and you would drop the remainder of 200. And then look at Great Basin. You have 1,800 people per square mile. Divided by 500 would be 3 blocks, but you have a 300 over 500 remainder. So we'd have to round up to the 4 blocks. When they complete these problems, they should see that there are 42 blocks total that they need for Legos to do the population density. All right, so they have done their division, and they now have double-checked themselves with the amount of Lego blocks that they need, and you can now distribute, or you can collect up their papers, grade them, because the next day when they come back, now they're going to make the actual graph. So you're going to give each set of students their baggie of Legos. You're going to give them their graph. And now they have to, looking at their worksheet from yesterday, they know how many blocks they need to have. So they need to decide right away what color I'm going to use, or they're going to use, because they can be in groups, for elevation, and what color they're going to use for population density. So in this case, we're going to use, for elevation, we're going to use blue. And for population density, we're going to use red. All right, and according to the worksheet from yesterday, that's where they're going to get their statistics from. We're going to start with the Pacific Ocean, and we need 2 blocks of elevation for the Pacific Ocean. Then I look down for population per square mile, and it's 8 blocks population density. So I need 8 reds. And I put them right next to each other. Now, if it's possible, skip 1 space before you do the next region. So the next region is 7 Legos that are blue for elevation. So it's 3, 6, 7. And I got to tell you, this was like the most popular activity in my classroom. They'd come in for days later saying, can we do Legos again? All right. And then we have population density. This is elevation. Population density, 2. And they go ahead and construct their graph. Eventually, they're going to have a graph that looks like this. Okay. Here's our elevation. Here's our population density, the white. Can you see the inverse relationship? Okay, where it is low elevation, there's a lot of people. Low elevation, a lot of people. Low elevation, a lot of people. Where there's high elevation, there's few people. All right, now we're going to have the students graph. And the graph is now a physical paper. They've made the kinesthetic model, and they can still use it. In fact, one of the things that I had kids do at some point was I actually had them just trace. They can trace the graph if you wish. But to make a more perfect graph, we now can use one example, has no labels, where they're going to be labeling the Pacific Coast, the Great Basin, all the way to the Atlantic, and then putting in their number scheme. Or if your students aren't ready for that, you don't feel they can do the total graphing, then they can use the second sheet, which is to have the number scale already present and the labels for the different regions present, and then have a title already on the map. So we're going to complete our graph, and we can do that with colors. So remember, elevation was 2, so I'm going to use black for elevation. Our population density was 7 or 8. And they can go ahead and complete their paper graph. Their graph, when they finish, should look like this. This would be the answer key. But the important part of the activity for me, okay, the math is good. It's good to do math. But the important part for me is now to look at the so what. The so what is what we want the kids to get out of this. So the questions are, which region has the highest elevations? The Rocky Mountains. Okay, but then when you start to look at what region has the fewest people, it's the Rocky Mountains. So, okay, we have the highest elevation, but we have the lowest number of people. Why do you think that would be? And they would have to come up with answers. This is where you need them to discuss. Well, it's a short growing season. People aren't going to be farmers there. There may not be a lot of industry. There's probably not a lot of transportation through mountains. That it's cold there. And so for various reasons, people don't tend to live where there are mountains. but yet they live along coasts. Why would people want to live along the Atlantic or the Pacific coast? The answer, again, lies in a lot of factors. You have transportation there. You have international transportation there. You have the possibility that people have factories there because they're taking advantage of the transportation. Therefore, there's jobs. Therefore, people want to live there. So you want to build the concepts in the kids' minds about why would people live in different places and choose not to live in others. Now, the students should be sharing their answers. Okay, the idea is for them to reinforce why would people choose to live where they do, and to understand that inverse relationship, that where there's high elevation, there's usually a low population, that where there's low elevation, you have a high amount of population. And then you can ask another math question, which would be, what other two concepts could we possibly graph that show a relationship? For example, if we graphed population density and the number of cars, do you think that they would be similar in height? Or if we graphed population density and wild animals, would they be similar in height, or would we show an inverse relationship again? So get them to think about what other things could show measurement by population or by elevation. All right, the assessments, the worksheets easily could be graded. The questions, why do you think questions could be graded? You can give more points for the why do you think questions because obviously those are harder than just questions that involve some sort of rote memory. And extensions. All right, there is a series of books on the different regions that are excellent to use to talk about these various regions. These books are available from National Geographic, and they can tell you the students more about the regions once you've tweaked their interest. You also can study the physical regions map, and then at some point give them a quiz. We have one variety that has all of the labels and another one that has no labels, so that they would have to fill in the different regions. And if students are able to use the computer lab, you could have them graph using the computer. And I want to thank John Daly Whalen, who was the person who created this lesson, and I'm just sharing it with you. So thank you to John for letting me use this lesson. Thank you.